All right, guys, I'm going to do a quick walkthrough of my day 2 polar homework. Again, just to kind of talk through all of the different things that I did to get the graphs that I have on the answer key up there. So if you need them, again, you can look at any of them. If you need to fast forward or anything, you can do that as well. So let's take a look. So looking at the first one here, we know we have a cosine graph, so a couple things we can think about. Again, there's an a value, and we can call it a k value if you're thinking of like a, b, h, and k along the way. The first thing I always do, though, is I always think, okay, if r is equal to 0, that would be, again, any points that go through the pole. And I like to do that first to decide how many points are going through the pole. That can kind of help you decide which type of limacon this is going to be. So if I put r equals 0, we solve it. We want to know where is the cosine 1. The cosine is 1 at 0, and there's only one place where the cosine is 1. So that means you only have one place where your graph intersects the pole there. So that kind of tells us right away that this is going to be a cardioid instead of one of the other limacons here. So then to get some other points along the way, again, we know this is a cosine, so that can kind of tell us that it's going to be symmetric to our horizontal axis. That can help us there. And then thinking through our points, I picked 0. We actually already solved for 0 over here. But then pi over 2 pi and 3 pi over 2, it's helpful to be able to get a little bit quicker at going through those basic points when you're doing your cosine. So you know the cosine of 0 is 1. 3 times 1 is 3, minus 3, again, that's what gives us the 0. Cosine of pi over 2 we know is 0. 0 minus 3, we get the negative 3. Cosine of pi is negative 1. So 3 times negative 1 is negative 3. Minus 1 gives us the negative 6. And then cosine of 3 pi over 2 is 0. So once again, we get negative 3. So I graphed those. So at pi over 2, notice again the positives would be up here, but the negatives would be down below right here. So we've got a negative 3. And then at pi, positives and the pi would be on the left-hand side over here, but the negative would be over here at the opposite direction on the right hand side here. So that's at negative 6. 3 pi over 2, again, we want negative 3. That actually corresponds to this point up here on the top half. And again, once we have those points, that's good, but we really want to be able to tell a little bit better of a shape of the graph. Really, you could pick any points you wanted to. You could choose to substitute in pi over 4 and pi over 6. However, the cosine of pi over 4 is square root of 2 over 2. Do you really want to do the calculations with that? Cosine of pi over 6 is the square root of 3 over 2, which again, you could do, but you're going to get some decimals along the way here. And if we're doing this without a calculator, we want to try and come up with some easier numbers. So we know that the cosine of pi over 3 is 1/2. So 3 times 1/2 gives us 1.5. 1.5 minus 3, we get negative 1.5. Again, if I'm on the pi over 3, I'm going in the negative direction. So that's why I'm actually going kind of down and to the left here for the negative 1.5. And then 5 pi over 3, that's the positive 1/2 again. Again, when we sub that in, we get the same point. Again, it's symmetric, so really you would only need to think through one of them and just think it reflects over onto the other side. Now, those points are kind of nice to have points. That can kind of help us see a little bit more of how the graph goes in like this, but really it's more beneficial to have the points kind of figuring out the rest of this curve and making that a little more circular and how far does it go out there. So I'm actually going to do the 2 pi over 3 and 4 pi over 3. Again, really you only need to do one of those because you know the other one's symmetric to the horizontal axis there. So cosine of 2 pi over 3 we know is negative 1/2. So 3 times negative 1/2 is negative 1.5 minus 3 gives us negative 4.5. So if I am at 2 pi over 3, but I'm going negative 4.5, that brings me kind of down the point here on the bottom. And then it would be symmetric for that 4 pi over 3 point over here for the negative 4.5 as well. That can help us get that better shape of the cardioid there. All right, looking at number 2 to talk through this one. I solved it when r is 0 to find out how many times it crosses through the pole, and it crosses through the pole in 2 different places here. That tells me that it's going to be that limacon with that inner loop, the loop inside the loop here. because it crosses through twice along that way. So kind of what it does is it kind of goes in the loop and crosses through and then comes out of the loop and crosses through once again. That's why it has 2 points. Like if you were to trace over it, it would trace over that twice. So it crosses through 2 times. So again, I picked my normal points. Here we know that the sign of 0 this time is 0. That's why we get -2. Sine of pi over 2 is 1. That gives us -6. Sine of pi is 0. We get -2. Sine of 3 pi over 2 is -1. We get +2. So that's how we graphed some of those main points here. Now if I think about some other points on here. Now I didn't pick 7 pi over 6 and 11 pi over 6 because we already know that that's going to give us 0. We know those are the places that it crosses through the pole. So I picked pi over 6 and 5 pi over 6. Again, when it's sine, I'm choosing the pi over 6's or that denominator of 6 because we know at all of those with the reference angle of pi over 6 gives us either a 1/2 or a -1/2. So the sine of pi over 6 we know is 1/2. -4 times 1/2 is -2. -2 gives us that -4. And again, we can graph that. So if I'm at pi over 6, the positive is next to that pi over 6 part, but we're going -4. That can give us this point here. Because it's a sine, we know it is symmetric to our vertical axis. So we could do the 5 pi over 6 or really just think it's reflects over. And that gives us that better shape of this limacon here, that curve. All right, looking at the next one, number 3, we can actually go even quicker here because hopefully maybe you recognize this from the stuff we did earlier this week here, that number 3 is just a circle. Notice that this has that a value, but it doesn't have a plus or a minus next to it. Whenever that's the case, we know that this one is just going to be a circle. If you were unsure, I wrote down all of the points on here. But really a lot of these you could probably do in your head. Again, you know it's a cosine, so it's symmetric to the horizontal axis. It's a negative, so we know it's going to go to the left of the axis here. And the 6 in front tells us that's our furthest distance away from the pole. Really, that ends up being the diameter of the circle. So if I picked the 0, pi over 2, pi, and 3 pi over 2, that gives us the point at the pole, the point furthest away, the point at the pole again, and again the point furthest away, and so forth along the way. So if we look at those, that can kind of help us tell that it's going to be a circle. I like to pick at least another couple points to think through. So if we're doing a cosine, again, think about the numbers that are easy with the cosine. All the ones with a reference angle of pi over 3 are going to give us either 1/2 or -1/2. So I chose pi over 3. And cosine of pi over 3 is 1/2 times -6 is -3. So if we're at the positive pi over 3, going -3 would bring us in that opposite direction here. Again, it's symmetric, so I just thought through it's going to be that reflected point on the other side. Really, we could probably do the 2 pi over 3's and so forth along the way. That might help us within some of them, but really that's just going to give us those same points here. So that gives us at least a little bit better of a curve. Mine could be a better circle there, but you get the idea. Looking at number 4, when you solve it with r equals 0, we can tell again that there's no solution here. When we know that there's no solution, we know it's still a limacon because of our, general pattern of our equation here. But if there's no solution, we know it's not going to be a cardioid or that loop in the loop. So it's either going to be convex or one of the flat side ones. Again, really the difference between those two I'm not all that concerned with, just the fact that you know kind of the general idea of what it might look like here. So when we're looking at these, again, I picked my basic points here, substituted it in, and got our values. Again, picking through some of the other points, I did all of the pi over 3's. Really, it's pretty quick and easy because, again, you know it's going to be a half or -1/2 right here. So that gives us 4.5 or 3.5 for our two values. Graphed those, and again, you can kind of tell that this side is a little bit of that flatter side. Almost looks like a circle, but kind of like it's been pushed in a little bit and made that side flatter over here. I'll look through the rest of these here. Number 5, once again, is a circle. You'll notice I didn't really do any work for that. I did it all in my head. I did still think through those points. But because we know it's a sine, we know it's symmetric to our vertical axis. It didn't have any pluses or minuses, so we knew really that our furthest point away from the pole is at 5. And again, it's our circle. I picked our pi over 6s because we know that's where it's a half. So 5 times a half would give us 2.5 at those points, and that's how I've got the shape of that circle. Number 6 here. Again, I put r equals 0 in. We found that there's no solution again, and there's no point where the sign is -3/2. Again, it's only between -1 and +1. So that tells us again that it's a limacon that's either maybe convex or has a dimple in. Again, for right now, for our purposes, I really just kind of want you to know the general idea behind it. We'll get into some of the other stuff a little bit later. But I picked my 4 points here, plugged them in with those numbers and got some general shape of it. Again, I wanted to get a little bit more specifically the ones on this curve here. So I chose pi over 6 and 5 pi over 6 because the sine of pi over 6 and 5 pi over 6 is 1/2. This one you can kind of tell is one that has a little bit more of that dimple in it if you were to figure out some more of those points. Number 7, when we solve for r equals 0, there are 2 places where it would cross through that pole. Again, that tells you that it's going to be that inner loop. Again, it crosses through the pole once, finishes the loop, and crosses through it again. So that's how we know it's the limacon with the inner loop. Pick those 4 points, substitute them in. Again, I chose the pi over 3s because that's where the cosine is 1/2. Notice this one I did not choose 2 pi over 3 or 4 pi over 3 because we know that would give us 0. That's where it goes through the pole. But we can get a couple of those other points in there to get a better shape to our limacon there. Last one, notice it has one place where r equals 0, so it crosses through the pole just at pi over 2. Because it just crosses through once, we know that's a cardioid. It's a sine graph, so we know it's symmetric to our vertical axis. Picking our same 4 points gives us part of the graph. The pi over 6s, you'll notice again, I did them all just because I thought it was really pretty quick with the sign of pi over 6 and all of our other numbers in there, giving us 1/2 or -1/2. And that kind of rounded out our graph and got us the cardioid. So let me know if there's any further questions on this. We'll do some extra practice with it, and we'll continue on with a new type of graph on Monday. All right, bye guys.